And this one's take a look at finding the derivative of 1 over x from the definition. So step by step from the beginning. So here is f of x equals 1 over x. Step 2, I need to find this quantity limit as h goes to 0 of the following here. F of x plus h minus f of x divided by h. So step number 3, wherever you see x in the original f of x, you just stick in x plus h first. So be the limit as h goes to 0 of, now you're going to put 1 over x plus h and then minus 1 over x, and then all of that still divided by h. And that 1 over x, wherever you see x, you first replace it with x plus h. That's the first move. And then when you put in f of x, that's just 1 over x. In the bottom, you put h. Remember, this is the difference quotient. And then you take the limit when h goes to 0. That gives you the expression that represents the derivative. So when I do this here, let's go through this process. Here, to save time, I'm not going to write the limit as h goes to 0 until the very end. But it's really kind of implied to be present. I'm just going to work on this fraction to simplify it. So I'm going to say 1 over the following, x plus h minus 1 over x divided by h. So here, I need to somehow combine the two fractions in the top of the big fraction. So a way of doing it is as follows. Take a look. This is x plus h and this is x. For example, what I can do is multiply this one here by x over x. And how do I know that I should do that? Think back for a second. X over x is a form of the number 1. You're always allowed to multiply by 1. And I'm multiplying by that over here because x plus h doesn't have just x as a factor by itself. It has x plus h. So I'm multiplying by x over x, which is a form of the number 1. For this one over here, I'm going to multiply by x plus h. Like that, x plus h. And I'm doing that precisely because x by itself doesn't have x plus h. So now when I look at the bottoms, I have x times x plus h, and I have, again, x times x plus h. You see the bottoms match. That's what we want. So at step number 5 down below here, this is going to be x times 1, which is x, minus, and now be careful. This negative should distribute over to the x and the h individually, right here in this position. So it's going to look like this, in other words. I'm going to say minus x minus h. So this negative you send over to the x and you distribute it to the h individually. That gets people? All of this is kept over the combined bottom, which is x times x plus h, and all of this is still then over h. So I'm just, again, simplifying the expression. Let's move on. At the next, step 6 here, we can simplify. At step 5 back there, we had x minus h. You see that the x's should really cancel. Like this will cancel with that because they're of opposite sign, naturally enough. So here I'm going to put now negative h over x, and then x plus h. And all of that's still over h. Now, here, if you think about this, this is just going to use a basic rule of fractions. Keep, change, flip. So if you want to be very explicit, you can put that h in the bottom over 1. If that helps you to see the pattern of keep, change, flip. So that means specifically you're going to keep negative h over x times x plus h. And the bottom fraction, which right now at step number 6 was h over 1, you flip that. So it's keep, change to multiplication, and then flip the bottom so it becomes 1 over h, like that. At the next stage, at step number 8 that is, notice that this h will cancel with that h. When you cancel here, be very careful. Remember, there's always a 1. So this is like negative h times positive 1. That also gets people frequently because they just cancel off the h and somehow turn that into I'm not sure what. So leave that 1 on the top. That's going to leave you the following at step 8. Negative 1 over x and then x plus h. Now this expression we can take the limit of. So let's do that. Step 9. I'm going to go back to using the limit notation. So the limit as h approaches 0 of negative 1 over x times x plus h. So that's step number 10. Well, in this particular case, this expression doesn't have any more issues. You can just directly replace h with 0. So over here at step number 10, I'm going to do this. I'm going to say negative 1, like that, x, and then x plus 0. So this value right here represents replacing h with 0. And then I simplify this, so step 11 is going to give me negative 1 over x times x is x squared. And this basically is the derivative of f of x equals 1 over x found through the definition using the limit notation. And that is it. Thanks so much for watching. I hope this has been truly helpful. Leave a like. I'll see you in another video.